In this video, we will look at the vertical alignment and long sections that we use to define it. The vertical alignment is defined by a long section, which is easy to remember as a shape. It is the shape as you go along the road. This long section is for the road we looked at in the plan. It also has a drawing at the top of the table with a table below. The table entries provide information on the point directly above that on the drawing. The drawing shows the final road alignment as a solid line and the existing ground level as dotted lines. Note the existing ground has a flat part at the start of the road and then a steep slope which flattens out at the middle of the road. Here is a photo of the site before the earthworks were taken. You can see the steep slope drop down to a flatter area where the photo is taken from. This green line shows the approximate alignment of the road. From the long section, you can see that the photo was taken in an area that will be filled to bring it up to the design level. Back to the long section. Let's zoom in on one chainage point in the table, which is about the same location as where the photo in the previous slide was taken. The bottom line on the drawing is at reduced level of -16. That is, it is 16 meters below the datum. However, notice that all of the road is well above the datum. The bottom row of the table is the chainage. This point is at chainage 80, which means it is 80 meters from the start of the roadworks. Remember that we had chainages on the plan, so you can see where this point is on both the plan and the long section. The next row up is the CL design level, which is the level of the center line on the road. So at this point, the center line is at a level of 11.96 meters above the datum. The next row up is the depth of the cut or fill at that point, with fill shown as positive numbers and cut shown as negative. So we can see that there is 3.33 meters of fill required at this chainage. You can see this on the drawings as the design level shown in the bold line is well above the dashed line, which is existing ground level. The top row is the existing surface level, which is 8.62 meters and is obviously well below the road design level. You may have noticed these values above the table. They set out information on the horizontal and vertical curves as well as the grade of the road. Remember, the grade of the road is the slope. Horizontal curves are the bends in the road, while vertical curves are the undulations. The purple lines show the straight grades of the road. You can see that the road slopes one way to the left and the other way to the right. The slope on the left has a grade of -8.42%, which means it falls 8.42 meters vertically for every 100 meters of horizontal distance. The 134.39 L means the length of the slope is 134.39 meters. The slope on the right has a grade of 5.57%, which means it rises 5.57 meters every 100 meters distance, and the slope is 115.81 meters in length. Obviously, if you were driving the other way, you'd be going down the right-hand slope and up the left-hand slope. The orientation for a long section is as if you were driving from chainage 0 along the road. If the road was the shape shown by the purple lines, then the vehicles would change direction quickly when going from one grade to another. This would make for an uncomfortable ride for the passengers, and also the driver could lose control. You would have experienced this when driving on bumpy roads. We want the road to provide a smooth, comfortable ride, so we design a long, smooth curve into the road so the car changes direction smoothly when changing grades. The curve here is defined in red. Looking at the table, the 100 VC means that it is a 100 meter long vertical curve, and the extent of the curve is shown by the arrowed line. You can see that it is 100 meters long by comparing the chainages. The curve starts at chainage 114.49 and ends at chainage 214.49. The difference is 100 meters. The 7.15 value under the line is called the K value, which indicates the abruptness of the change of the direction of the curve. A low number indicates an abrupt change, which means vehicle passengers are going to get bumped around when the vehicle changes direction. A higher number indicates a less abrupt change of direction, and the vehicle occupants are likely to experience a nice smooth change of direction. This curve is quite smooth. Designing these vertical curves is called geometric design, which involves some complicated calculations which are outside of the scope of this course.